Hello, my name is Punyha Singapore, or you can call me Aommy.
My name is Satchavintes or Imone.
And my name is Jidapayanut, or you can call me Tangmo.
My name is Tashino Subsaparupai, or you can call me Friendly.
My name is Yararat Anjinda. I am Punyha.
And today we are going to present a physics project about the spring dynamic launcher.
So let's get started. The objective of our project is to investigate the projectile motion of a ball launched by a spring and to see how changing the angle and distance affects whether the ball goes into the hoop.
We built a small basketball-style launcher. The material we used were wood, cardboard, acrylic color, popsicle sticks, paper cup, bottle cap, rubber band, soft clay, and hot glue gun.
Our project is based on projectile motion, which describes how an object moves when launched into the air.
So the projectile motion has many equations, such as in the experiment, the springing provides the initial velocity by changing the launch angle, the springing compressions, and the distance of the hoops.
We observe how these changes affect the projectile path. When we increase the launch angle, the ball travels higher but shorter in distance. When we decrease the angle, the ball went farther but lower. This matches the theory maximum range happened around 45 degrees. We tested our launcher many times and measured where the ball landed compared to our predictions.
We will explain how to play correctly. First, placing the mini ball into the launcher. Second, using your finger to gently pull back the launcher to build force.
Third, aiming at one of the basketball hoops is actually the cups. Focus on where you want the ball to go and land.
Each ball that lands in a cup warns the points, trying to score in the higher hoops for more points. Lastly, keep shooting and trying to beat your high score.
So the first formula is the horizontal distance, and this tells us how far the ball travels left or right, and it depends on the initial speed from the springing and the launch angle and the time the ball is in the air.
The second formula is the vertical height at any time. This shows how high the ball goes in the air. Gravity pulls the ball down. This equation describes the curved shape of the ball's path.
Next is the time of flight. This tells us how long the ball stays in the air before hitting the ground. A higher angle means more vertical speed, so the ball stays in the air longer. Higher angles, more time in air. More times, the ball can travel faster.
The fourth formula is the maximum height. This helps us predict how high the ball will rise. If the angle bigger, the vertical path of the speed is bigger, so the ball reaches a higher peak.
And finally, the range equation. This formula predicts how far the ball will land from the launcher. It shows that the distance is greatest when the angle is around 45 degrees, which is exactly what we observed during our experiment.
Using these equations, we compare the predict part with our actual results. Even though our launcher had small errors like frictions, air resistance, or the ball not launching exact the time in each time, our results still match the theory very well. We hope our explanation was easy to understand.
And thank you for your time and attention. Thank you.